In this video, we explore how the Dutch protect communities from an infamous river's flooding. And it may just be the world's quietest job site, as everything you see here is battery powered. The saying goes, God made the world, but the Dutch made the Netherlands. With the Dutch reclaiming 20% of the country's total landmass from previously uninhabitable land and 26% of the country being below sea level, it's safe to say they're the global experts in coastal defense and reclamation work. This brings me to the star of today's show, Van Oord, a family-owned global marine contractor with 155 years of experience in this subject. Not bad at all. The last time we visited Van Oord was in Denmark, where they, alongside other marine construction giant Boskalis, dredged an enormous channel for the future Fehmarn Belt fixed-link tunnel. Beyond the dredging, they built kilometers of new coastline and breakwaters to protect the new marine sanctuary. Today, we're in the Netherlands, but instead of on the coast, we're safely inland, about 100 kilometers from Amsterdam. And I'll explain everything, but first, let's start on site. The Waal River, which flows west from Germany, is typically tame. But the Netherlands, about the size of West Virginia, is remarkably flat, introducing today's problem: widespread flooding during the spring thaw. With the lack of elevation, the river can become over 2 kilometers wide, threatening many communities along the waterway. In the Iron Age, about 1,000 years ago, the Dutch first built dikes along the river to tame the water. Originally built snug to the river, most dikes have since been reconstructed further from the typical flow. This allows floodwaters to fan out across a greater surface area, slowing the water and lowering the high water mark. Because these dikes are essential, the National Flood Program has evaluated the network, identifying which stretches don't meet safety criteria. And this 20-kilometer stretch from Tiel to Waardenburg required reinforcing. Reinforcing the dikes happening in 2 ways. 1, major earthworks, widening and raising the existing structure in key areas with about 1.65 million cubic meters of dirt and clay. Second is the sheet pile reinforcement with about 9 kilometers or 18,000 metric tons of steel to drive into the earth, forming an impenetrable flood barrier. A consortium between Van Oord, Ploegrim, and Dura Vermeer began the work in 2013 with completion slated for 2027. With that, let's go check out the world's first fully electric job site.
So 330, they've extended the reach, and they've widened the tracks, so it's...
Yeah, it looks wider.
And they added extra weight, Leon?
Yeah, extra weight.
Really?
Different cylinders, so it's slightly stronger.
Oh, really? Oh, bigger cylinders. Wow, yeah.
Again, that's also why the steel plates work, eh?
The steel plates are brilliant. You'll notice with the nice drone footage that the entire haul route is covered with these steel plates. The steel plates allow them to operate when it is muddy, like today is. It rained all day yesterday. It's quite soft. This would be a complete disaster without these steel plates, but no problem. They can drive on them just as fast as normal. And they also remove substantial rolling resistance, which helps these electric tractors with the battery power. They can drive a lot further with these steel plates, reducing that rolling resistance than otherwise.
We've opted for a fast charging module. So you see another battery behind there?
Yep.
It should last 24 hours. So the excavator can work 8 hours and it needs recharging twice.
Okay.
Once during the morning break and at the 12 o'clock break.
Okay.
And then after the lunch break, it's being collected, recharged in 2 hours, brought back before 6 o'clock in the evening because the excavator needs a night charge.
Okay.
To be really full again. Then it works 2 hours, 2.5, it gets a breakfast charge. So there's a whole module by which it can work about 8-9 hours. A bit depending on the wetness of the clay and the strength it requires to do the work.
So at lunch, the excavator will just track over to that module there.
Yeah.
He'll just plug it in, charge it while at lunch, and then just go back to work.
Right.
Okay.
Exactly how it works, yeah. And what's special is that we've laid it all out so it can charge at 350 kilowatts, which is for fast charging really fast.
That is one of 4 Caterpillar 330 battery machines out here. That's one of the only battery electric 30-ton excavators in the world. It's a pretty amazing machine. It has a long boom, long stick on it, widened undercarriage for additional stability. They've added some additional weight to it. It has a tilt bucket. The bucket itself is extraordinary because it has that chain back, which prevents the clay from sticking. The first time I've seen a bucket like that, and it is brilliant. The machine has the battery pack built into that back. You can see the cover there. The batteries are within, underneath where the engine would be. Instead, has the batteries there. 3D GPS on it as he's cutting this slope. Boot holders on the outside of the cab, one of the most important features. And then at lunch here in an hour or two, he tracks the machine right over to that Connex looking trailer, which is a bigger battery, fast charging. We'll charge that machine up while the operator's taking a break so that he can then go back to work. Yep. No sticking clay here.
Ben, kan je met je Engels of niet? Klein beetje. Kijk, nou hier, dit is Aaron Witt, dit is een YouTube.
Hello.
Hi.
Wow.
Here, you can come and take a look here.
Yeah. Oh.
Kan je de capaciteit van de...
Yeah, that's a fancy.
De gegevens van de batterij ook allemaal laten zien, of niet? Van je kraan. Wat bedoel je? Nou, je
Oh, so you have your battery there.
Yeah.
74% charged.
Yeah.
Wow, yeah, that's a whole different display, huh?
This is the temperature.
Temperature for the battery.
Yeah.
I see.
And this from the machine.
Battery temperature,
Yeah.
machine temperature.
It's very important.
Okay.
Yeah. And here's the remaining work hours. And
Yep.
the average power.
So you have 4 hours remaining.
Yeah. Remaining work hours, yeah.
But then at lunch, he'll just track it over there and charge it back up
Yeah.
as needed.
Yeah.
As we saw, not only does that 330 have the cleanest cab I have ever seen, but also no engine, as it's 100% battery powered. This applies to almost every machine on site, 40 in total, all powered by onboard battery systems or trailing cables, a first of its kind worldwide.
These tractors are quite unique because almost all of them are battery powered. You'll see the enormous battery pack hanging off the front of the tractor that gives it a few hours of juice. And then over there's that orange and white Van Oord giant battery that is charging up the other tractor batteries. So when the batteries on the tractors are out of juice, they pull them off, they put them on that bigger charger, replace the batteries so the tractors can keep moving all throughout the day, and then that bigger battery is charged at another point, so it's good to go for the shift. The theme of this project is electric equipment. The crane is no exception, but the power system is a little bit different. Down there, we have the battery packs, and you can see a cable from there to the crane. The crane is somewhat stationary. It's moving very slowly as it's driving these sheet piles. So we can plop the batteries there, run that cable, run the crane with battery so that the batteries are not on board and can be exchanged very easily outside of the machine.
The work area shown by the drone footage is tight. Family homes are on one side with protected environmental areas on the other, limiting all construction operations to the footprint of the dike itself. To reduce truck traffic through the nearby towns, most materials arrive at the project by barge, with offloading by material handler, then transport with the tractors and trailers we saw earlier. With record-high nitrogen oxide levels, the Dutch government has begun seeking ways to reduce the emissions from machines and vehicles working throughout the country. With this project being so close to critical environmental areas, they challenged contractors to see how much they could cut while still performing the project. But it wasn't as simple as buying all the machines and charging infrastructure, as no one has used battery machines at such a scale. So the joint venture team had to work with equipment suppliers like Pond Caterpillar to build the necessary machines. Using large mobile recharging stations, these 330 Z-line excavators built at Pond's shop in Amsterdam consume about 800 kilowatt hours of power in an 8-hour shift. But all this effort has resulted in a 94% reduction in nitrogen oxide on this project.
CCS2.
Oh, that's where you plug it in?
Yeah, the CCS2.
Okay. So that's where you plug it in from that big charger over there. All right. Oh, wow. So those are all your batteries right there, huh?
Back there.
Oh, they're back there.
Yeah, they're back there. Big battery box.
Yeah.
So you see that we turned the pump
Yeah.
90 degrees. So
Okay.
it's more this way. So we have more space for battery packs.
Okay.
And also the fuel tank
Yeah.
being swapped with a battery pack.
Really?
There are four packs now.
Wow.
And that's a big distributor box where all cable leads can come together.
Okay.
Now we'll flow to the motors.
Okay, so all these cables are from the batteries,
Yeah.
and then from there it goes to the motors.
They come from the battery and
Yeah.
they go to the inverter, which will go to the motor.
Okay.
When you look on top, you can see the battery pack.
So it goes, which powers the hydraulics?
This one.
Yeah.
This is the hydraulic pump.
Yep.
This is the motor which drives the pumps.
Okay. So you have your batteries, inverter, motor, drives the pumps,
Yeah.
which drives the machine.
Yeah. So normally this is connected to the diesel engine.
Yeah.
But it's turned. 90 degrees, so it's facing that way.
Yeah.
But it's the same pump as we use on the diesel machines.
Okay. That's amazing.
Yeah. You can see the cooling there. It's cooling from the pump, is water cooling. See there?
Oh yeah. Wow.
Now for the charging. This is the world's first heavy equipment charging station, fed by on-site wind turbines and solar panels.
This is where they charge the batteries for the tractors, cranes, other pieces of equipment. The excavator batteries are on trailers and are driven here after hours, but these are here for midday. So this is an electric mega box. It has 385 kilowatt hours of power that can be stored within it. It's a giant battery. Here is another one next to this one being charged right now. So it's plugged in. You can hear the fans keeping it cool as it's charging. And then you have your hub right here. It is at now 94%, 356 kilowatt hours. You can see it going up 16, 17, 18, 20, actually charging quite fast. So once this is charged to 100%, it's then put onto these trucks with cranes. They're very heavy with cranes, then driven to the job site, replacing the old or the used batteries. Then the used batteries come here and around we go.
But because most of the grid is AC, we wanted a system that is can be charged by AC, because the next project it could be somewhere out there in the corner of the world.
Yeah.
Then definitely you got AC available.
Yes, because you need to convert it.
Indeed.
Yeah.
But rather than the charging point converting it to DC,
Yeah.
this battery has got a bit more range. So that's AC in, power lock, and then it has inside itself is a fast charger. And to show you now, see, in here you've got the same fast charger in a mobile version as you got standing there on the.
I see.
And by that system, CCS2, you can fast charge the excavator.
Okay, so that's what you plug into the excavators.
So here it's got two wires, so now you can charge an excavator and a tractor or whatever.
So this, how many?
Different philosophy kind of thing.
How many kilowatt hours is this?
800.
800.
870.
Yeah.
So 870, almost 900. So you charge that, and then this afternoon, a truck will come and grab this,
Yes.
bring it over there,
Get the night jobs for the brains
and get the other one.
Yeah, in the morning the machines are full. This one gets back, and the other one gets back.
So this must be really expensive then.
Oh yeah.
What a stupid question.
So you have AC going in, it's converting it to DC
Yeah. And
on
then it's-
board to
so
charge
AC
itself.
indeed, stored as DC.
Yeah.
And it has then a fast charger built in to really fast load up an excavator or whatever.
I see.
That combination is also fairly unique.
So
we
this
got
is, I
six
mean-
of those. You see that the green lights, that it's working, all that.
Yeah. This is as fancy as it gets.
It does. It does. It
Anywhere.
does. Yeah. They're heavy. I mean, they're 14,500 tons.
Yeah.
Charging station.
So you had to build this
Yeah.
for the project.
For the product.
Wow.
And nowadays you see slowly on that you got alternative clients coming along.
Yeah.
So that would be like dirt collectors or logistical companies.
The logistics of this is.
Yeah, this is Hank's job.
Yeah. Whoa. Wow. Okay.
After seeing where they charge up all the batteries, we headed to our final stop of the visit, where Van Ord was finishing up a section of the dike.
Real quick, this is more topsoil export to other parts of the project. They've stockpiled it here. This is the soil necessary for things to grow that they want to cover the outside of the dike with. So the clay they're importing won't grow anything. That's being used for the interior of the dike. That's that waterproof layer. And then on top of that, they'll be putting this material on it. They'll seed it and it'll grow nice and pretty, and it won't just look pretty, but all of that vegetation will help hold everything together during rain events. This 352 custom built stick boom, widened undercarriage, the same chain style bucket that we saw in the 330. This is a conventional machine. You can hear the diesel engine purring. You can hear that hydraulic pump, those hydraulic pumps humming away. It's not an electric machine, one of the only non-electric machines on this project.
What you see here is this is a bit of the river bank that we have completed. So it is less steep than it used to be.
Yeah.
We added clay, water-resistant clay, which is the highest category. And on top of that is about 15 centimeters of ordinary soil that can be used for growing grass on it. But underneath it is that first layer of clay, and that really makes the riverbank thicker, stronger, and more resistant to high water.
So you were adding, the existing dike was here, and you were
existing dike
adding.
Was here. It was smaller and it was way steeper.
Okay. So you've added.
We've added and
out and up.
And up.
And how? The locals. The river is pretty low right now.
It's very low at the moment, actually.
Okay. So it's very low. When does it get quite higher?
So. The normal layer would be, I would say, you see the sand there?
Yeah.
That would be like just touching the water. So definitely 4 meters higher than this. It's very low now.
Is it in the summer will it get higher? Is that typically the season when it gets higher?
Actually, this is the time it normally is rather high.
Yeah.
Because the snow is starting to melt.
Yeah.
So no, but because it's been really nice, and also it is partly dependable on rain.
Yeah.
And we haven't had hardly any.
Okay.
So.
But this entire area, from where we're standing on this dike to then those trees over there, could all be water when it's high.
All be water. It's all one big floodplain.
Wow.
Wow.
So all the groins would be covered. That would be like the first stage. Then you got here what we call a bit of a summer dike. And then that gets flooded too, and then it gets up to 1 or 2 meters below here. And there have been multiple floods, and then it becomes, that's the last line of defense, huh? Then it's
yeah. So when it floods, if this dike wasn't there, that entire community is underwater.
Sure.
Wow.
Sure.
Okay.
It's a very Dutch problem.
Yeah. The river is all the way out there. You can't even see it, but all of that is a floodplain. If and when this floods, it can come to about a meter of where we're standing right now from this dike. So all of that land would be covered with water. Now, if you look right here, you'll notice I'm standing almost as high as the top of that house, 2-story house with a little bit of an attic. So that entire homestead there, that entire community, all of this land that way would also be underwater if it weren't for this earthen structure we're standing on right now and that they are in the middle of reinforcing. This is great. Yeah.
Great.
Yeah. Yeah, this is really nice.
I hope you like it. So,
Yeah. Yeah, appreciate you guys taking us around.
Yeah, you're welcome.
No, it was a really good project. Yeah, really good to meet
Thank you.
Yeah,
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 have a good
yeah. Thank
one.
you very much.
Thank you.
Yeah, thank you guys.
Hey, thank you too, eh?
Thank you.
Thank you so much to Van Ord. They are a monster company. It was very kind for them to have us out here in the Netherlands to check out not just a monster dike reinforcement project, but also what it takes to keep an enormous electric fleet running. I learned quite a bit. I hope you did too. We'll see you on the next one. Subscribe if you liked this. We've got so much more coming. Stay dirty.